So let's do another example here. Let's do an example in which we've got a rectangular, or rather, let's say a cube. We have a cube. On one end of the cube is a sphere, and then another sphere is connected to the other side of the cube right there. And the entire thing is spinning around its center of mass. So that's kind of an oblique view. So this is oblique view. And then top view. Okay, we've got the rectangular object, we've got this, and it's rotating around the center right there. So let's say that each of the little side things is mass m1. Okay, let's say that the rectangular cube, or rather the cube rather, is m2. Let's say that each of these things on the end has the same radius, r1, and let's say that r1 is going to be equal to 8.91 centimeters. Let's say that m1 is going to be 1.25 kilograms. Let's say that this has a side length of a, and so let's say that m2 is going to be 3.61 kilograms, and a is going to be equal to 22.0 centimeters. Okay, and so I want to know if the entire thing is spinning with an angular velocity of 15.0 radians per second. I want to know what is the kinetic energy of rotation. Okay, so kinetic energy of rotation is just 1/2 I omega squared. So we know what 1/2 is. I gave you omega, so all we have to do is find I. Now, if you look in the table, you do not have I for something like that. Okay, so you have to figure this out. Well, what you do have in the table is you have for a rectangular block, we're trying to find this. So what you do have is you have for a rectangular object like that, okay, if that's A and that's B and it's going around the center of mass, you know that I equals 1/12 m a squared plus b squared. You also know that for a sphere going around its center of mass, that I equals 2/5 mr squared. So how do we use that here? Well, for the rectangular block right here, A and A, because it's really a cube, okay, then I is going to be 1/12 m2 a squared plus a squared. So that's going to be 1/6 m2 a squared. Okay, so that gives us that. So we now have that thing in the middle. What about the two spheres on each end? Well, they're not rotating around the center of mass. Around the center of mass, I was 2/5 mr squared. They're not rotating around the center of mass. They're rotating around an axis over here that's a long ways from the center of mass. In fact, the axis is outside the sphere itself. Well, that's perfectly fine, because if you look down on this from above, you've got the cube in the middle, you've got the sphere, there's the axis rotation. So as this thing goes around, each sphere, the center of the sphere is some distance big R out, and the sphere is rotating because this end of the sphere is now up here. It's going to be over here. It's going to be at the bottom down here. So each sphere is rotating as it goes around. So that means the I total is going to be equal to the mass of the sphere times r squared plus 2/5 mr squared. Okay, so all we have to do is figure out what is big R. Well, big R is going to be that distance, so it's going to be A over 2 plus R1. So that's going to be A over 2 plus R1. Okay. So that means the I of the spheres the I of the spheres, there's 2 of them, so that'll be 2 times 2 fifths m1 r1 squared plus m1 times r1 plus a over 2 squared. Okay. So the total I, remember we got the object here. Total I is just adding up all of that. So the total I is going to be equal to 1/6 m2 a squared plus 2 times 2 fifths m1 r1 squared r1 squared plus m1 times r1 plus a over 2 squared. So this is going to be equal to 1/6 m2 a squared plus 4/5 m1 r1 squared plus 2 m1 r1 plus a over 2 squared. All right, so if you just plug in all the numbers that we were given at the very beginning, that comes up to I equal to 0.194 kilogram meter squared. So you know that K equals 1/2 I omega squared. So that's going to be equal to 1/2 times what we just calculated, 0.194 kilogram meter squared times 15 radians per second squared. And so the kinetic energy comes out to be 21.9 joules.